So now we're ready for addition reactions. With addition reactions, we're going to start with a double bond, and we're going to add two things, one to one carbon and one to the other carbon. There are going to be a couple of things we're going to have to be careful about. One is if the two carbons here are not identical, which one gets the X and which one gets the Y. The other thing you're going to need to be aware of is if we've got a double bond and we're adding, we can add both to the top side or both to the bottom side. Let me show you what I'm talking about. Let's get rid of that one and redraw it. This is our original framework. We can add both of them to the top, or we can add one to the top and one to the bottom. The way you're going to determine which carbon gets the X and which one gets the Y, whatever we're adding, which ones add from the top and which ones add across the double bond, top, this could be the top or the bottom, of course, is you're going to need to know the mechanism. When we discuss each one of these addition reactions, there'll be a mechanism with it. And if you remember the mechanism, then you'll be able to figure out where to add the groups. Okay, so pi bonds are reactive. They can function as bases and steal protons. They can also act as nucleophiles. And if they're acting as a nucleophile, they will attack an electrophile. Okay, so we're going to go through all the different types of addition reactions we'll be studying in the chapters. Kind of a short summary. The first one here is halohydrogenation, and you're going to be adding a hydrogen or a proton to one side and a halogen to the other, either chlorine or bromine or iodine. Hydration, as you might expect, you're adding a hydrogen to one carbon. The other carbon is going to get a hydroxy. That makes water. Hydrogenation, we add a hydrogen to both carbons. Halogenation, we add a halogen to both sides. It'll either be chlorine or bromine to one side and chlorine or bromine to the other side. Hydrohalogenation is going to be a hydroxy on one side and a halogen on the other to be chlorine, bromine, or iodine. As you might expect, dihydroxylation, it means you're adding two hydroxys. So you're adding a hydroxy to one carbon and you add the hydroxy also to the other carbon. Alkanes are found in nature and industry. In nature, they're found in garlic odor, perfumes, waxy coatings on apples, orange smell, turpentine, and cholesterol. Pheromones too. In industry, they're produced from cracking petroleum and used to make plastics, polyethylene, PVC, polypropylene, acetic acid, ethylene glycol, acetone, isopropyl alcohol, ethanol. They're actually, ethanol doesn't have an alkene, it's just used in making it. So that's my introduction. We'll jump right in with the next one.